All right, so with this, you're given a scenario. You're told that this is the flight of a ball thrown at a speed of 14 milliliters or millimeters per second, whatever it is, and we have to find the maximum height of that ball. So I'm sure we could graph this by all means, and there's a lot of different characteristics we could see. We could see at what height the ball is initially thrown. That would be your y-intercept. Our x-intercept would be where the ball lands. So there's a lot of things that this graph could tell us, but this specific problem is only asking us what's the maximum height. So all we really need to do is we don't really necessarily need to graph anything. We just need to find the max. So we can do that through, again, the vertex. So we know our axis of symmetry is x equals opposite b over 2a. Now some of you might say, uh-oh, this is an x, this is a t. T and x are the exact same thing in this problem. T is your independent variable, x is your independent variable. T is representing time in this case. So I guess it's t equals opposite b over 2a. So b, opposite b will be negative 14 over 2 times negative 5. So we end up with negative 14 over negative 10, which a negative divided by a negative is a positive, so we have positive 1.4. So time is 1.4. What that is that's just saying at 1.4 seconds, that's when this ball is going to reach its maximum height, when it's thrown straight up into the air. So we take that time, that 1.4 seconds, plug it in up there, and see what the actual height is when it reaches that maximum. So we'll do negative 5 times 1.4 squared plus 14 times 1.4 plus 3. So again, follow your order of operations, do parentheses first. Well, there's nothing inside the parentheses. We can simplify, so now we do the exponents. So we have to do 1.4 squared, which is here. Multiply that by negative 5. Okay, so 1.4 squared is 1.96. Multiply that by negative 5, we get negative 9.8. And we're going to add 14 times 1.4 to that, which is 19.6, and we add 3. So we have negative 9.8 plus 19.6 plus 3, and we get 12.8. So that means, and I forget the label for this, but after 1.4 seconds, the ball will reach its max height of 12.8, I don't know, feet, millimeters, I don't remember what it is we were using. So 12.8 is the maximum height. So obviously you can kind of see where this is used in the real world. If you wanted to see, depending on how fast you throw a ball, how high it could make and how long it would take, you could do this. We just have to know the equation that represents that. So it's a pretty neat concept. If you have any questions, feel free to ask.